start the recording. All right. Seeing as not everyone is here, no one wants to use up their Friday afternoon of isolation. Or I guess it's morning for you guys. All right. So today, first, so I haven't marked your tests yet because I had 4 tests in the same week, so I'm just kind of plowing through those. But we're getting there. We're getting there. So, and you guys were the last ones, so you kind of didn't really luck out there. So today we're gonna start chapter 7. So hopefully you saw the handouts that I posted on Moodle. So usually, like as always, handouts are posted on Moodle. So of course I can't give you printed copies, but it is just, I think, 4 pages, so not too bad for us to just go through. So I think we're supposed to do 7.1 and 7.2, but maybe 7.3 today if we have time. I'm just kind of feeling like the more we can get done today, the better, right? And then the 3 of us, let's see if there's still just 3 of us. Yeah, then the 3 of us, oh, hey Arinder, the 4 of us. Can do something else. All right, so, all right. Sorry, just a sec. Hey, did you get this emergency alert? Great. Sorry, we just got an emergency alert. I don't know. Anyways, just it can wait, I guess. All right. So if we start in chapter 7, so chapter 7 is a little bit different than what we have been doing, right? And so a lot of this stuff, especially 7.1, we're going to be working towards proving identities, which like we'll do a lot of these together, but for the most part, when we're talking about identities and kind of proving things, a lot of this is just you plugging through it on your own. And I mean, most of these are just practice problems and just kind of stuff for you to work on. So like I said, as always, we'll go through a couple of these together, but just to get used to using these what we call trig identities, it's just going to be a matter of practice on your end. So so chapter 7 introduces trig identities, which we use in proofs. So proofs are essentially all of math, right? And so when we're doing proofs, I'll show you the ropes. I'll show you some of the tricks that we can use. But for most of these problems, it's going to be a matter of you practicing all of these and just getting better at seeing trig identities that you can use. So for most of these problems, it will be a matter of you practicing on your own to get better at spotting trig identities that you can use. Okay, so for basically all of chapter 7 is just a big puzzle, right? And so think of proofs as puzzles, right? So I can show you how to lay a puzzle, but at the end of the day, it's just going to be you sitting down and actually figuring these things out on your own. And I know that doesn't feel good as a student, because sometimes when you look at these things, it's not going to be the easiest thing to see right away. But the more you do, you'll get quicker at spotting, oh, I see you know, a cosine squared. I know there are some trig identities that I can use there, for example, right? And so what's nice for you guys is because you'll be doing your tests, so your final exam, right, at home, you'll have all these, so you don't have to remember these. But even on your formula sheet, oh yeah, so Chloe asked, let me see here. Oh yeah, so the format for the final exam, oh, we still haven't landed on something. I think everyone's just trying to figure out what to do for the rest of the term, and so we have been putting it off a little bit. It might just be kind of a wrap-up test, or it might touch on some of the old stuff. But we have to coordinate with the rest of the sections. So, so I'm kind of hanging out waiting for that. So kind of as a side note here to address the, so format for the final is still undecided. Okay. Oh yeah, but you will have a review package. How about I'll put that here. But you will get a review package. Okay, and you will be doing it at home. So it will be done at home. So it's kind of assumed that it's open book, right? So assumed to be kind of open book, right? We can't watch you or anything. So it's kind of, we just assume that you have all these resources available to you, right? And so unlike the usual, so what we've been doing before, right, is just using those questions that we've given you, right? And so the questions will not be exactly like the practice, right? Just as a heads up, because that's what we have been doing. But and we did do that for test 2 because I was kind of like, ugh, whatever, who cares? But for this final, whether it covers everything or if it just covers, you know, what's missing, that's what we're deciding. But for the final exam, there will be a final exam, and it will be in the regular time. You'll get a review package. We're kind of assuming it's open book, so that's why it won't be exactly like the practice, but the practice will prepare you. Okay. So let's see here. Oh yeah, so if we're talking about, so section 7.1 is just introducing the idea of trig identities. So 7.1 is called trigonometric identities. So oops, here, hopefully you've got them in front of you, so I'm not going to make them bigger. And let me just check just make sure I didn't miss anything. Oh yeah, so wait, so Galaxy A50, I don't know who you are, but can you hear me now? It should be. Can everyone else hear me? Awesome. I assumed you could hear me actually, Chloe, I guess, because we've kind of been chatting, but that's awesome. Okay. Galaxy A50. I don't know who you are, but can you hear me now? Oops. Okay, well, I guess that's all I can do. All right. So trig identities, right? We're gonna kind of get familiar with all of these identities, but even if you go to the formula sheet that you would have gotten, right, during the test, right, all of these trig identities would be given, right? And so just as a rule, right, you're not really expected to memorize all these. Some of them you will commit to memory just because of if you're using them a lot, right? And you'll notice that there are some kind of go-tos. From the formula sheet, right? And so you've got these ones. Oops, I'm trying to do these are the most common or commonly used, I'll say. Right. Those are the ones that you'll definitely want to be able to at least recognize, right? And some of these, right? So the Pythagorean identities we've actually already used, right? Remember when we were preparing for, I think it was maybe in chapter 6 with the trig substitutions, right? And then the even odd identities are here. So let's just have a look here. The Pythagorean identities are the first ones. The even odd identities are also given. The cofunction, I don't think they're given. No, they are, but only some of them, right? Only the more common ones. And so some of these got confusing there. And do we need the reciprocal identities? No, not really. I don't see them on here. Were they on the previous page? Perchance. Laws of logs? No. So to me, that tells me we don't really need them. Right. So if they're on the formula sheet, then yeah, you should probably spend some time recognizing those, right? And otherwise, it'll be something that, you know, if you have all these identities available to you, then you can work through the problems, but not something to memorize. No. Okay. So, oops, wrong there. So first thing, we'll start off small, and we're just gonna simplify these trig expressions. So one trick that we use is just kind of rewriting things in terms of sine and cosine, right? And so that's kind of a trick that we can use, and so we're going to practice doing that here just to start. And so the first thing that we'll do, let's do number 3, just to start off nice and slow. If we've got cos t times tan t, and you can wrap these up in brackets if you want to, or if you don't want to, that's fine too. Okay, so we want to write these in terms of sine and cosine. So what I'm seeing is that cosine is fine, but the tangent I want to rewrite. And so I can look at my trig identities and I can say, okay, well, the tan of x is the sine of x over the cos of x. So in this case, instead of x, we've got t, but what we can do is we can rewrite this as the cos of t. That one stays the same, right? And then I'm rewriting tan of t as sine of t over cos of t. Sine of t over cos of t. What's nice here is that this cos of t cancels with this cos of t, right? So all I'm left with is the sine of t. Right? So now that's how I'm going to go ahead and just simplify the rest of these. So let's do 7 and 8 together. Right, I'll leave the rest of them to you. So 7 has tan squared x minus secant squared x. Oops. Secant squared x. One thing to remember, and I think we already talked about it. Oh, I see a chat here, sorry. Oh, nice. Okay, great. Thanks, Interpret. Okay, so one thing to remember is that, and I think we mentioned it before, but I honestly can't quite remember, is that if we have something like the sine squared of x, that's the same as sine x all squared. Okay. It just looks nicer than writing the sine of x squared, because then there might be confusion and say that the x is squared, which can happen, right? And so what we do is instead we put it on the sine.
Message
Oh, say what? Oh, hang on, missing some. Okay. Hello? Interpret has their hand up. Hello? Do you mean to have your hand up? Oh, hey.
No, it is by mistake.
Oh, okay. So I'll ignore it then. All right, cool. Let's see here. So here, right, so we write the sine, the squared, on the sine instead of the x, because otherwise it can get confusing. Because we can take the sine of x squared, right? So if we, so unless we write the brackets around and then put the square on top, it's just a notation thing. So the main thing to remember is that the sine squared x is actually sine of x all squared. right? And so those are equivalent. And we're actually going to use this to move around. And so that applies for sine squared x, for cos squared x, for tan squared x, for secant squared x, for cotangent squared x, for cosecant squared x, all of those, right? We could think of them as moving the 2 on the outside, or the square on the outside. So here, right, if we want to rewrite these in terms of sine and cosine only, right, then what can we do here? So what we're going to do is we're just going to search our options here. And so I see a tan squared x in this identity, and that might actually work out nicely because I've also got a secant squared x, right? And so what I can do is I can rewrite this, so tan squared x and then secant squared x. Let's put that over here on the roster. So we can use the tan squared x, oops, t squared. Tan squared x, is it plus 1? Plus 1 is secant squared x. Let me just confirm that. Yeah. Okay, so let's remember that. What do I have here? Well, I can make this look a lot like this, or at least rewrite this to make it look a lot like this, right? And so what I can do is I can say, okay, well, if I have tan here, oops, if I have tan squared x minus secant squared x, that's the same as moving this over here, but also moving the 1 over to the right-hand side, right? So I can manipulate this identity and say that that's going to be the same as tan squared x minus secant squared x. Secant squared x, which is -1. Right? That's still true. Okay. So what I'm going to do here is I'm going to say, well, that's equal to -1 from here. Right? I could leave it at that, and in fact, I would probably argue that that's the simplest form of so write it in terms of sine and cosine and then simplify. I'd argue that that is the simplest form, so we're done. Another way that we could do this is, so, or, well, tan squared x, if we've got our, let's use this instead, right? Let's do what it told us to do and rewrite it in terms of sine and cosine. So then tan squared x is sine x over cos x all squared. And then secant squared x is 1 over cos x all squared. So let's use that instead. So, or we can rewrite tan squared x as sine x over cos x all squared minus 1 over cos x all squared. You know what I should do just to stay proper? I should shift this over to the right-hand side of the equal sign so that I can, oops, so that I can start fresh here. Right, I'm just doing this another way. But I already know that I should end up at -1 from that first time that we went through it. So here we go. So if I bring in this square over to the sine x and the cos x, I'm allowed to do that as long as I'm only multiplying and dividing in there. So I end up at sine squared x over cos squared x minus 1 squared over cos squared x. What's nice is I've got a common denominator here, right? And so I can combine these and say, well, that's the same as sine squared x minus 1 over cos squared x. Now what can I do? I can rewrite this. I can use, I would say this is the most common identity that we've got, right? Sine squared x plus cos squared x is 1. So I can rewrite sine squared x plus cos squared x equals 1, and I can use that here, right? Because if I rewrite, so if I use the fact that sine squared x plus cos squared x is 1, right? Then I can rewrite, if I do a little rejigging, right? Then I get sine squared x minus 1 is, so what I'm doing is I'm moving this one over to this side and the cos squared over to this side, making it negative cos x squared, or cos squared x. Right? And so here, that's what I'm going to use here. So I end up with, and I'm just putting it on a fresh page here, I get negative cos squared x over cos squared x, which is negative 1. So regardless, it puts me at negative 1. So you can see there's always lots of different ways that you can go about a trig identity and just kind of simplifying it. I'd say this was way quicker, right? Way faster than putting it in terms of sine and cosine. But if you're ever in a jam, right, putting things in terms of sine and cosine will always work out, right? It might be a little bit more work, but that will always work. Okay? So that's, if you're stuck, then your first plan of attack, and that's why we're doing these problems, is to convert it into sine and cosine and just kind of see what unfolds. Right? Okay, I'll check on this end for questions, but I think we're all good. Yeah. So let's do question 8 then. Secant x over cosecant x. So our first plan of attack is just, let's have a look at these identities. And this is what I mean. So a lot of your job here is just going to be to get familiar with, and if you want to use these ones or these ones, they're the same, right? So I just find these a little bit cleaner to look at. So I'm going to look at these. But so I've got cosecant x is 1 over sine x. And now I can't remember what the other one was. Secant x is 1 over cos x. So what I'm going to do is I'm going to replace these because I actually don't see any other suitable replacement. So that feels the easiest to me to get it in terms of sine and cosine. So what I'll actually do maybe is I'll copy this one here, bring it down so that I have it. Oops. There. So secant x I'm going to replace with 1 over cos x all over cosecant x I'm going to replace with 1 over sine x. What's nice here is we've got a fraction over a fraction, which we've worked a lot with. So 1 over cosine x, so we know how to deal with this, times, and then flip and multiply sine x over 1. This works out to be just sine x over cos x, which looks like tan x to me, right? So to simplify it even further, right, we would put it in terms of just tan x. Nice. So I'll leave the rest of those for you guys to do, but just make sure that you are patient when you're doing these things, right? And just kind of as a general plan of attack, just convert things to sine and cosine if you don't see an obvious exchange, right? And then just follow the identities that we have. So now what we want to do, right, is we want to simplify these trig expressions, right? So we just want to simplify these, whereas before it told us to put it in terms of sine and cosine first. So now there might be some other ways that we can go about it faster, just like we saw earlier here with the tan squared x minus secant squared x. So let's see here. Okay, which one should we do? Maybe let's do some of these trickier ones. Let's start with 26. So we're just simplifying these things, and I know that's kind of vague. So the cotangent of capital A minus 1 over 1 plus the tangent of negative A. Oh, I guess I should write out, I can't remember if we talked about what these things are called. So there's sine x, which is just the sine of x. There's the cos x, which is the cosine of x. I think these ones should be familiar. Tan x is the tangent. And then we've got cosecant of x is the cosecant. Oops, I don't think there's a hyphen in there. Cosecant. Secant of x is the secant. And the cotangent of x is the cotangent. And so those are all the ones that I've just been using willy-nilly, but hopefully they're pretty straightforward. So that's just what they're called. So I've got the cotangent of A minus 1 over 1 plus the tan of negative A. So at first thing I'm reacting to is the tan of the negative, right? And so I know that there's these even odd identities. And that just comes from me being familiar with all the things on here, right? And so until you've worked through enough problems and kind of seen, oh, I can latch on to this tan of negative A and rewrite that as the negative tan of A, right? I think that's going to be my first plan of attack here. So I'm going to leave the cotangent of A as it is on top over 1 minus the tangent of A. And sometimes we head down dead ends, right? And so what I did kind of, well, it was on purpose actually, was that I didn't work through any of these beforehand, just because then there's a risk that I just kind of plow through these and say, well, obviously it's going to be, you're going to make this replacement. So instead of doing that, I wanted to just kind of work through the thought process with you guys. And so my first thought is to deal with this guy and simplify him a little bit and rewrite it as 1 minus tan A. There's a chance that I have to go back and backpedal here, but so far I'm feeling pretty good about it. Right? So we want to simplify this, and so what I've got is I've got 1 minus the cotangent of A minus 1. And so there's only a few places where I see the cotangent. I've got this one here, the 1 plus the cotangent squared. The cotangent of x is cos x over sine x. And basically, we're not really dealing with any cofunction identities. We'll know when we've got something in this form inside. So those seem to be my only options. I'm leaning towards using this one so that I'm not introducing a cosecant squared, right? That's we can deal with that, but I think it might be easier to just use the cotangent of x as the cos of x over sine of x. So that's the next thing that I'm going to do, is I'm going to say, okay, well, that's the cos of a. So whatever's on the inside, cos of a over sine of a minus 1. And then I'm going to make the same replacement because I know that the tan of a, the tan of x is sine x over cos x. And so maybe that'll get me somewhere if I replace these sine x over cos x. Right? So I get 1 minus sine a over cos a. Okay. So what I'm going to do is, I've got a fraction over a fraction essentially, but I have to get these over a common denominator, both of them. So what I'm going to do is I'm going to have cos a over sine a minus 1 times sine a over sine a to get that common denominator over 1, and then times cos a over cos a to again get that common denominator, minus sine a over cos a. So now I get cos a minus sine a over sine a over cos a minus sine a over cos a. Okay, now we're getting somewhere, right? Because now, again, I've got a fraction over a fraction, and so I can flip and multiply, and so I've got cos a minus sine a over sine a times cos a over cos a minus sine a. Thinking of these guys as wrapped up in brackets, right, and we're just multiplying here, well, then they cancel because they're the same. Cos a minus sine a can cancel with cos a minus sine a. So all I'm left with is cos a over sine a, which I can rewrite as cotangent of x, or cotangent a. Oops, make that look like an a. Nice. All right. I'd say that's simplified. Okay. How about we do 28? Okay, 28. So like I said, me going through these with you, I'm just showing you the ropes. We're not going to do a huge amount of these because it is better that you do them on your own. So let's do 28 here. I'm just going to steal it because I don't want to. Oh, there. Two plus tan squared x over secant squared x all minus 1. So we're just simplifying this thing. 2 plus tan squared x over secant squared x minus 1. Okay. So, a couple of things that I'm seeing. I'm latching on to the secant squared x, but also the tan squared x. I think there's some things that we can do here. And maybe I'll copy this again so we have it close by here. Because what I'm seeing here, right, is the tan squared x, I've got the secant squared x. I'd say if you had to memorize just two identities, these two Pythagorean identities should be it, right? It's assumed that you remember tan x, right? So for the three kind of go-tos that you have to remember or memorize, commit to memory, I would say those three are the most important ones. Okay? So as soon as I see this tan squared, secant squared, I know I'm going to be able to do something with this identity here. Okay? It might take longer, but we could just replace the tan x with sine x over cos x, and same thing with the secant x 1 over cosecant, or cosine, right? It just might take longer, but that's okay, right? Sometimes that's fine. Okay, so those are kind of the go-tos. All right, so how do we want to approach this thing? I think maybe what I should do is rewrite this -1 as something over secant squared. So what I'm going to get, and just because I put this thing here, I'm going to put my equal sign here. So 2, or maybe I'll just give myself a little bit more room here. There. So what I'm going to do is I'm going to do 2 plus tan squared x over secant squared x. And like I said, just like before, there's a chance that I'm heading down a rabbit hole that I might have to retreat from later, just if it gets too out of hand. But you, as long as you stick with it, you should be able to simplify these things no matter how you approach it, right? And so if you see something that you want to try, then go for it and see what happens. Because now I've got 2 plus tan squared x minus secant squared x all over secant squared x. Okay. If I do the same thing that I was doing before, right? Tan squared x, move the secant squared x over here. So I've got the tan squared x minus secant squared x. That's going to be the same thing as -1, right? And so what I'm going to do is I've got equals 2 plus, and then the tan squared x minus secant squared x, just over here, tan squared x minus secant squared x is -1. So plus -1, right? That goes there. Over secant squared x. So now I've got 2 minus 1, which is 1, over secant squared x. What else can I do here? I can simplify this a little bit more, right? Now what I'm looking at is probably the secant x, right, is 1 over cos x, because what I can do is I can rewrite this as 1 over secant x, and then I'll try to highlight the things, the changes that I'm making here, all squared, right? Because even if I bring this in, 1 squared is just 1, and then if I bring that square on the secant, then I'm left with what I have up top here. So as long as you're not changing anything, then you're safe. So that's going to be 1 over secant x all squared. I can replace the secant x with 1 over cos. See where that gets me. It's going to put me at a fraction over a fraction, 1 over cosine of x all squared. And okay, again, I've got a fraction over a fraction. So I've got 1 over 1 times cos x over 1. Remember, it's still all squared, which puts me at cos x over 1 all squared. But I can just rewrite that as cos squared x. Okay. Of course, as soon as I'm teaching, my dog's like, hey, what are you doing? Okay. So we did it. We simplified it to just cos squared x. There's lots of ways that you could have done this, right? So play around with it, see what happens. But as long as you end up with the same identity, then you're good. Okay. So just as a rule, right? Because what we're going to move into is actually proving trig identities. And so if we're proving trig identities, then we've got things that look like, let's see here. We've got these things. Well, and even on your handout, right? So now, if we want to prove, so verify that these identities are true, so sine theta over tan theta is the cosine of theta. If we want to prove something like that is true, then we're doing proofs, right? And so even, well, actually, I could have just looked here. All of these we could prove, right? So we can use, probably some of these would require some other trig identities, right? These are just some of them. But in general, we can prove all of these to be true, right? And that's how they're established as fact. And so if you're proving trig identities, what's nice is then you've got something like this, right? And so you start with the more complicated side often, and then you're trying to work your way to the other side, right? And so you know what you're working towards in each of these situations, right? And so I find that that's a lot easier, and that's what makes it just a puzzle game, right? Is you're just working towards all of these endpoints, right? And there's lots more on the handout that you've got, or that's on Moodle, right? Even more here. In fact, maybe what we'll do is we'll work through some of these harder ones instead, right? And so I'll remove this one, delete. Okay, but just as a rule, so I'll paste these in here. You're going to start with one side. So usually you pick the grosser side, so the larger side or kind of the more difficult side, and then you're transforming it to look like the other side. So you're going to just use the known identities, so use the identities that you have, and just kind of morph the bigger side to look closer and closer to usually the right-hand side or the easier side. Like I said, if you're stuck, right, then your go-to is going to be to convert to sines and cosines, right? Like we saw, sometimes it'll take a little bit longer, but it'll definitely get you there, right? It'll get you to the end eventually. So if we do, and you know what, I'm just going to crop these. Let's just do, let's just do these last three. So here I'll just say, prove the following. So these are the ones that we'll do together, and as you saw, there's tons more. But what's nice is you don't really need solutions to these. If you're able to make it look like the right-hand side, then you did it, right? You'll get solutions, but and just to see one way of getting to the 2 secant x. But what's nice is once you're here, right, on the easier side, right, then you're done. So 71. We've got 1 over secant x plus tan x plus 1 over secant x, oops, almost put a square on that. Well, I did put a square on there. Secant x minus tan x. Prove that it's equal to 2 secant x. Okay, so we did start on the way harder ones, right? But I think it's better that we work through these together. And then you can have the other ones for yourself. Let's see here. Just gonna copy, because we'll definitely need to use these identities. Let's see here. Erase that. Okay. So what are some things that we can do? I've got a secant x and a tan x in both of these, right? One's being added, one's being subtracted. So I'm just going to see if there's anything that I can do here to make that work. Well, I could do something weird, right? I could rewrite this tan x as plus tan of negative x. I don't think that would help me that much, so I'm not going to do that quite yet. I've got tan squared and secant squared. I might just go for replacing secant x with 1 over cos x and tan x with sine over cosine. See what happens, right? And that's our go-to move. So if you're scanning here and you don't really see any obvious exchange, then that's safe, right? To make these old boring changes. So secant x I can replace with 1 over cosine of x plus tan x, which I can replace with sine x over cos x. What I'm noticing right away is that what's nice is I have a common denominator right away. So that's pretty good, pretty juicy. Plus 1 over secant x, which is 1 over cosine of x, minus tan x, which is sine x over cos x. And okay. Usually what I would do is I would write this stuff over here, right? And maybe that's what I should do, just to make it look proper. I'll put these identities up here. Oops. Move them up a bit. Okay. And then what I should do is I'll move this over here, because what you'll see is that we actually want to show that we work from here towards this. So what we do is we have 1 over secant x plus tan x plus 1 over secant x minus tan x is equal to that. That's a fact, right? So usually this is how we write it out. And then we're trying to morph this side eventually to look like 2 secant x. So I think she has to, are you off your phone call? Yeah, okay, cool. All right, so again, right, we've got these common denominators, which are pretty nice. So we've got 1 over 1 plus sine x over cos x plus 1 over 1 minus sine x over cos x. Okay. I can flip and multiply, right? I've got a fraction over a fraction. So I've got 1, technically over 1, times cos x over 1 plus sine x plus 1, technically over 1. I'll just put those there. times cos x over 1 minus sine x, remembering that these are being multiplied, which is cos x plus cos, oops, can't combine them yet because we don't have a common denominator. Cos x over 1 plus sine x plus cos x over 1 minus sine x. Okay. So let's see what kind of magic we can pull here. Just put them, undo, copy. Put them over here instead. It's going to be all over this handout, okay, or all over my notes, because we need them all along, right? And so what I've got is, okay, I've got cos x, I've got sine x, I've got cos x and sine x again. The only solution that I'm coming up with is to put these over a common denominator, right? So that's going to make things a little bit messier before they get better here. So I've got cos x over 1 plus sine x. The common denominator that I need to get is times 1 minus sine x over 1 minus sine x plus cos x over 1 minus sine x, but to get it over a common denominator, I need to multiply it by 1 plus sine x over 1 plus sine x. Okay, like I said, it's not going to be pretty quite yet. So now I'm going to be at, I guess I'm just multiplying this out, multiplying these out. I'm curious to know what the denominator looks like, more than kind of the others. Yeah, I don't see anything jumping out at me. Maybe it jumps out at you, but I'm just going to have to keep going. Cos x minus cos x times sine x over, and then 1 times 1 is 1 minus sine x. So 1 minus sine x plus sine x minus sine squared x. This goes away with this. Okay, looking better. Plus cos x plus cos x sine x over, and then I know because I've got that common denominator, right, it should be the same as this. So you can confirm, but it should be 1 minus sine squared x. Okay, I've worked towards that common denominator, so I'm just going to get it there. So I've got cos x minus cos x sine x plus cos x plus cos x sine x. Seeing some things are going to cancel. Over 1 minus sine squared x. All right. Haha, things are looking up. Minus cos x sine x plus cos x sine x, those cancel. So now I've got cos x plus cos x, so I get 2 cos x over 1 minus sine squared x. Okay. Here we go. This is starting to look, now just bear with me, it's starting to look a little bit more like 2 secant x. What makes me say that? Well, I've got the 2 here. So I just want to make sure that I can morph this into secant x. Okay, because I've got the 2, and that I would say that's the hardest thing to come by, right? And so here we go. Anything that I can replace to make this more like secant x. I think I see it. It's a two-phase thing, but I'm going to use my go-to identity of sine squared x plus cos squared x is 1, right? Because if I move the sine squared over to the right-hand side, then I can replace 1 minus sine squared with cos squared, 1 minus sine squared with cos squared. So then I get, let me write it here, right? Sine squared x plus cos squared x equals 1. And so cos squared x is 1 minus sine squared x, which is what I'll use here. So I get 2 cos x over cos squared x. Remember, cos squared x is just the same as cos x squared. So what I can do is I can cancel this with one of these. So I'm left with 2 over cos x, or it'll look even better if I write it a different way, if I write it as 2 times 1 over cos x, because 1 over cos x is secant x. Ta-da! Which is what we wanted. Two times secant x. Bing! Oof. So it is a lot of work. Let me just check if I've got any. Okay, nice. Good. But you will get there eventually, right? And so here, I'm sure there were fancier ways that we could have gone about and solved this, right? But just going ahead and figuring out what these, rewriting this in terms of sine and cosine, eventually we were able to get there, right? So it took a while, but we got there eventually, right? And so this is not something that I can teach you necessarily, right? It's just going to be practice, like I was warning you all along. So that was 71. How about 72? Did you go outside? What a lucky girl. What a lucky girl. So let's do spending a little bit more time on this than I planned. That's all right. Let's do 72. Or is 73 harder? I feel like 73 looks a lot like 71. Let's do 72. So let me see here. 72, I'll just grab it so I'm not scrolling around all the time, and start on a fresh page down here. So we want to show that cos squared t plus tan squared t minus 1 over sine squared t is the same as tan squared t. So what I'm going to do, right, is I'm going to start with the nasty side, right, and morph it into the easier side, right? That's always the easiest way to do it. So cos squared t plus tan squared t minus 1 over sine squared t. And so here, this is where I'm going to do all my work, and eventually I should end up at tan squared t. Okay, so again, I'm going to be stealing this one here. May as well copy. Where can I put it? Here, maybe. Or here. There might be good. All right. So I'm seeing a lot of squares, which is making me want to go in here, maybe. All right, I've got a cos squared, which is here. I've got a tan squared, which is here. and I've got a sine squared. Let's see here. What's going to be nicer? Or do I just replace tan squared with sine squared over cosine squared? Maybe that's the way to do it. All right. Well, let's see here. Oh, I know, I see what I can do. I can use cos squared minus 1, right? I can rewrite those together, and I can say cos squared minus 1 is the same as negative sine. Let's start there, see what happens. So I've got cos squared t minus 1. All right, just kind of grouping those together, plus tan squared t over sine squared t. All right, I want to replace cos squared t minus 1 with negative sine squared t plus tan squared t over sine squared t. Okay. And sometimes I'll just kind of see it fall in, but that's because I've done so many of these proofs before, right? And so, but what I'm seeing is that I could rewrite this in terms of sine and cosine, and then I'm going to end up with probably a sine squared, cosine squared, and then those will cancel out. So let's see what happens here if I rewrite this in terms of sine squared x, or sine squared t over cos squared t. So we've got negative sine squared t plus, and we've got sine squared t over cos squared t over sine squared t. Okay. I'm going to want this, before I can join these, I have to get them over a common denominator. And so I want negative sine squared t times cos squared t over cos squared t plus sine squared t over cos squared t all over sine squared t. Okay. All right. Let's combine these here. So I've got negative sine squared t cos squared t plus sine squared t over cos squared t. Over sine squared t. What I'm feeling good about here is maybe I've got a fraction over fraction, right? So let's get these all on the same playing field and see what happens there. So I get negative sine squared t cos squared t plus sine squared t over cos squared t, and then times, so sine squared t over 1 becomes 1 over sine squared t. What I'm seeing now is I've got a common multiple of sine squared t that I could probably cancel here. So I'm going to pull that out. Equals, and I'm not going to do the negative, I'm going to leave the negative on the cos squared. So I've got sine squared t times negative cos squared t plus 1. Don't forget that plus 1 over cos squared t times, oops. And then the sine squared t can just be written down here, sine squared t. Now, because I've pulled out this common multiple, I can cancel those. And so now I can rewrite this as 1 minus cos squared t over cos squared t. So what I've got is equals 1 minus cos squared t over cos squared t. Okay, let me just remind myself where we're going here. Just tan squared. Okay, well, we are there. Why are we there? Because 1 minus cosine squared, again, using sine squared plus cos squared as 1, right? Here, sine squared t plus cosine squared t is 1. So 1 minus cosine squared is sine squared t is 1 minus cosine squared t, which is what I'm using here. So I've got sine squared t over cosine squared t. Ta-da, see where it is? This I can rewrite as sine t over cos t all squared, which is tan t squared, which is just tan squared t. We did it. Okay. So like I said, where did these questions go? 73. What I want to do, I want to get into 7.2 instead. So I'm going to leave the rest of these for you guys to work through, and don't expect these to be quick, right? Notice how many steps it takes, right? These are the harder ones that we're doing right now together, right? But so expecting it to be fast, that's not how these are going to work, right? You're going to have to just kind of puzzle your way through it and just kind of work through it, and once you start to see you know, all these little swaps like this that you can make, then it's really fun. It's really fun to work through these. And so, and I know that it's not fun in the beginning, but once you kind of start to see these little swaps that you can do, right, and noticing here that you're done, you just have to show the next few steps. There's nothing more rewarding. So just give those a go and try them out. I'll check to see if there's any questions on here, but I don't see any. So I think we should go into 7.2 then. So 7.2 is just more formulas. So addition and subtraction formulas is on addition and subtraction formulas, which are also on your formula sheet, I'm pretty sure. Let me just copy these in. And just see here, paste. Oh, maybe I'll make it smaller and put in from your formula sheet that you would have gotten. And as part of the trig identities, let me put them side by side and see if we can map these, because they are there. Oops. Okay. So we've got the formulas for sine and cosine. And so the formulas for sine are here, and they're here. Whee. The formulas for cosine, right, addition and subtraction formulas are here. And for tan, or the tangent, they're smushed here. Oops. So they were all on there, right? So it's not something that you need to worry about. They'll just be given to you, right? And so in Calc 1, there's no formula sheet, but if you ever needed something weird like this, then it would be given to you, right? So you don't have to memorize anything like this. It's possible, the only ones that we expect you to know in calculus is basically these first Pythagorean ones. Okay, so these are all on here. So what are we doing here? Well, if I've got the sine of some s plus t, then I can rewrite this out, so I can expand it out essentially as sine s times cos t plus cos s times sine t, right? And so it's just another way that I can expand these out, because often it's hard to deal with something like s plus t or s minus t. And so that's why there are the addition and subtraction formulas. So often it's easier if we can just expand them out, because notice here we've got the sine of s, the cosine of t, the cosine of s, and the sine of t. So we're not dealing with this addition or subtraction anymore. And that's the whole goal of this section, is just introducing you to how to expand these things so that you can use them in your proofs. So, and here, right, basically, so there's the last two questions here, but besides that, the only questions that you have to do for 7.2 is just proofs, right? So prove these identities. And I want to, okay, let's just start with an itty bitty one just to get the hang of it, right? And then we'll go to the later ones. So 25, we're going to prove this identity. So we've got the sine of x minus pi over 2, and we want to prove that it equals negative cosine of x. So using the subtraction formula for sine, right, this becomes the sine of x times the cosine of pi over 2. Just making sure you use the right one. Sine of x times the cosine of pi over 2 minus the cosine of x times the sine of pi over 2. Now you can use your calculator, right? The cosine of pi over 2, make sure you're in degree or radian mode. Radian mode on your calculator, right, for both of these. So make sure that you can change to radian mode and then take the cosine of pi over 2, and what you'll find is that it's 0, right? Or you can use the special triangles from before, but I'm actually really bad at using those. So here, this is 0 from our calculator. And sine of pi over 2, I have a sneaking suspicion, but here we go. The sine of pi over 2 is 1 from our calculator. So what we get is we get sine x times 0 minus cos x times 1. Well, that's 0 minus cos x, which I don't know about you, but I think that's negative cos x. So we're done. And so that's just an itty bitty one. But that's the idea, right? And so you identify your first variable, which we're calling s here, and then your second variable, whether they're adding or subtracting, right, is going to determine which identity to use. And then this is your t, and then you can just expand it and see what happens. So let's do, I'm tempted just to look at 42. I think it might take us a little bit to do. So a lot of these are going to be pretty long, right? Okay, especially because I'm seeing 1 expansion, 2 expansions, 3 expansions, 4 expansions, right? And all I'm going to end up with is tan y. So I guess we'll see once we get there. But I'm going to start with sine x plus y. So just rewriting the right-hand side, or sorry, the left-hand side here, so that I have it sine of x minus y over the cos of x plus y plus the cos of x minus y. And here we go. So first thing I'm going to do is I'm going to expand each of these individually. Because I'm ending up at tan y, I suspect a lot of these things are going to cancel out, right? And so let's see what happens. So we've got the formulas for sine, whether we're adding or subtracting in there, and cosine, so we need to keep these straight. And I think what I'll do is I'm just going to copy these so that I have them on hand here, mostly for me. Okay. So I've got the sine of x plus y is the sine of x times the cosine of y plus the cos of x times the sine of y. To show that that's from the first, so that's just this one, right? I'm going to put those in brackets, and it looks like I'm going to need a lot more room than I gave myself here. So hopefully I can squeeze it in. Maybe I'll shrink this a little bit. So that's this one, right? And I'm going to put it in brackets just to make sure that I keep track of that. And then do the same thing for the next one. So now I've got sine x minus y. So now I've got the sine of x times the cos of y minus the cos of x times the sine of y. Okay. All right. And that's all over. So luckily I'm not going to have to deal with any common denominators quite yet, right? And so what I'm dealing with here is just okay. This one, I'm going to start down here. Same thing in brackets here, trying to write it small. So I've got the cos x plus y is the cos of x cos y minus the sine of x sine y plus, and now I'm on to the fourth one, which is subtraction inside the cosine. So I've got plus the cos of x cos of y plus the sine of x sine y. And close that bracket. So now what I'm going to do is I'm going to expand this and just hope that things are going to start canceling out, right? Sine x and sine xy cos y, or sine x cos y looks like it might cancel, so that might be nice. And I'm going to give myself a little bit more room here. I've got sine x cos y plus cos x sine y minus sine x cos y. Don't forget about expanding this negative all the way inside, right? You don't want to forget about that because that becomes plus cos x sine y. Do the same thing on the bottom. Cos x cos y minus sine x sine y plus cos x cos y plus sine x sine y. Okay, looks like only some of these cancel here. Sine x cos y minus sine x cos y. Phew. How about in the denominator, I've got sine x, y. So negative sine x sine y plus sine x sine y. I think those can go away. And let's see what we've got now. Well, these are the same, so I'm just going to get 2 cos x cos y, right? And I've got 2 cos x sine y. So it looks like I get 2 cos x sine y over 2 cos x cos y. Cha-ching. These 2's are going to cancel. These 2 coses are going to cancel. Sine y over cos y. Dun, 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 dun. Oh, hey, we didn't have to go that far. It was just a lot of work here in the beginning. Is tan y. Which is sine y over cos y, which is tan y. Phew. So even though that got kind of nasty over here right in the beginning, once we were able to cancel stuff out, it wasn't that bad actually. And I thought that one was going to take a long time. Okay. Let's see here. Let's do something a little bit more interesting. Actually, let's do 41 because that looks pretty good. Let's do 41 together. Okay. So this one, just from the looks of it, right, I'm going to be able to work backwards in a sense, right, where I kind of morph these into the left-hand side of these identities, right? So instead of expanding, we're essentially kind of factoring it in a weird way. So starting with the left-hand side, because it's more complicated looking, I've got tan x minus tan y over 1 minus tan x tan y. Okay, I can use these angles, but because I've got these tans, I'm going to bring those over here. So if I've got something like this, right, tan x minus tan y, it doesn't behave the same as sine and cosine. So what I've got is the tan of s plus t is the tan of s plus the tan of t over 1 minus the tan of s times the tan of t. But this looks sort of similar to each of these, right? The hang up on this one is that I've got adding here and subtracting up here, whereas down here, right, I've got addition down here, but it matches the subtraction up here. So either way, we're a little bit in a bit of a jam, but that's okay. What we've got here, right, is we can say, okay, well, let me just look at this. What if I just pulled out this negative out front to see what happens? That might be one way to do it. Or my go-to, convert all these to sines and cosines. That might be a way to do it. Get it to match this. What should we do? It's not hard, it's just deciding what to do, which road do we want to take. So I think that I I think I'm going to try to go morph this to look something like this. All right. Just going to see what happens. So I've got this addition here that I've got a subtraction here instead. But what I can do is I can pull out a negative, right? Or is it better to just write it in sine and cosine? You know what? Because I'm waffling so much, let's rewrite it in terms of sine and cosine. So tan x is sine x over cos x, right? We can confirm here, but I promise it is. Sine x over cos x, so let's go there. So we've got sine x over cos x minus sine y over cos y over 1 minus sine x over cos x times sine y over cos y. Okay. Up here I've got a, I don't have a common denominator. So let's fix that. So I've got sine x over cos x times cos y over cos y minus sine y over cos y times cos x over cos x. And that's all over. And what I'm going to do is I'm going to get the common denominator over here as well. So what I've got is 1 times cos x cos y, right? Because that's the denominator of the other term. So over cos x cos y minus sine x sine y over cos x cos y. Okay, I've got the same common denominator everywhere, so it looks bad, but it's actually going to cancel out quite nicely. So we've got sine x cos y minus sine y cos x over cos x cos y over cos x cos y minus sine x sine y over cos x cos y. Okay, I've got a fraction over a fraction, and I can rewrite this as just sine x cos y minus sine y cos x over cos x cos y. Flip and multiply. I'll just show that that's what I'm doing, times the cos x cos y over cos x cos y minus sine x, sine y. Need more room. Whee. Here, right, this cos x cos y is going to cancel with this cos x cos y. So now I'm left with sine x cos y minus sine y cos x over cos x cos y minus sine x sine y, which I can replace with these little guys. Copy, paste. Okay, so if I use x as my s here and y as my t, then I've got sine s cos t minus, so that puts me here, right, minus, and I can rewrite this as cos s sine t, right, if I swap these. So this top portion I can rewrite as sine x minus y equals sine x minus y. from here. And then the other portion, right, so the denominator, cos x times cos y, well, a cos times a cos tells me I'm going to be in a cosine identity, right? And so, again, using x as my s and y as my t, then I've got cos x cos y minus sine x sine y. So that's the cosine of s plus t, which is the cosine of x plus y. Oops. Which is, pretty sure, the identity that we wanted. Sine x minus y over cos x plus y. I'm going to make sure that that's what it is. Sine x minus y over cos x plus y. Doo-doo, we did it. And I'll just show where this came from here. Nice. Okay, just check if any questions here. Nope. All right, then I want to do one last example, and I want to do these kind of weird ones at the bottom. Oh, question?
Yeah, can you please repeat this sum again?
Wait, this one that we just did?
Yeah.
Or which one?
No, this one, the 41. We did now.
Oh, 41?
Yeah.
Well, which, starting where?
From the second step. Like the way we multiplied it with cos y over cos y.
Oh,
yeah. Here.
Okay, so from here?
Yeah.
So, well, okay, so let's start from the beginning then. So what I did was I rewrote each of these tans in terms of sine and cosine.
Okay.
Because if I'm ever stuck, then that's what I have to do, right? And so, and that's going to be safe always. So then what I'm noticing here is I've got cos x and I've got cos y. So that's not a common denominator. So to get it under, so have the same common denominator, right? I take the denominator over here and use that here. And I take the denominator over here and use that here.
Okay.
Then I've got a common denominator of cos x, cos y, right? Cos y, cos x, but I could rewrite those the order, right? And so then I'm able to combine the numerator, right? Oh, sorry, it's down here. Combine the numerator over the common denominator. And that's what I did over here as well, right? I had 1 minus the sine x over cos y, sine y, cos y. And so my denominator here was cos x, cos y. And so that's why I multiplied 1 by that to rewrite it with the same denominator.
Okay. Yeah.
So the whole goal here, or the trick, is that we need a common denominator. And that's what you'll find with a lot of these proofs, is the first couple of steps is going to involve finding the common denominator, at least, once or twice. And then recognizing that we have a fraction over a fraction here, then we can flip this and multiply it. And that's what we did here. And that's when we're able to cancel some of these. And then we can rewrite this over this. But this we can swap, because it helps that we know that we're working towards this.
Okay.
Right.
Thank you.
No problem. Yeah, so they're not easy, that's for sure. Right. And just as a last example, I want to do maybe 66 from here. Right, this one's a little bit different. So we've got the difference quotient. So if we let f of x be cos x and g of x be sine x, then we can use the addition or the subtraction formulas to show that this is true. So what we've got is if we do 66, if we let f of x be cos x and g of x be sine x, okay, then I want to show that g of x plus h minus g of x over h is equal to all this, right? And so what I'm going to do is I'm just going to plug these in and see what happens, right? And I'm just going to keep going until I end up with something like this or something that approaches this. So if g of x is sine x, then I can replace this with the sine of x plus h minus the sine of x over h. Okay. This here, right, now I've got this addition formula. So the sine of x plus h, let me see here, copy, put it here, oops. So the sine of x plus h I can rewrite, and I'm going to use big brackets around it just so I don't lose track of the sine x, which has to be there as well. So I've got the sine of x cos h plus cos of x sine h, then minus the sine of x over h. Okay. So I can expand this in here. It's not really going to do a lot, but let's see what happens here, which is the sine of x cos of h plus the cos x sine h minus the sine of x over h. Okay. And let's see where we wanted to end up at here. Sine of h over the times the cos of x minus the sine of x times 1 minus the cos of h over h. All right. I'm seeing a common sine x and sine x here. So I'm going to start there and see what happens. So I'm going to group these just to take baby steps here. Sine x cos h minus sine x plus cos x sine h over h. Right, I just move these things around so that I can kind of group them as one thing. Okay. I can pull out a common sine x. Oops, let's see here. So I get sine x times cos h minus 1 plus, and then I'm going to leave this cos x sine h over h. Let's see if that gets me any closer. Let's see here. I'm just going to keep a reminder close by of what I'm working towards. Okay, so I want the sine of x. It looks like I've already got this sort of, right? Except I've got cos h minus 1 instead of 1 minus cos h, but I also want the negative here. So maybe what I should have done is I should have pulled out a negative sine x, which puts me at negative sine x makes this negative and this positive. Right? We'd have to change the sign when we pull out a negative. And actually, we're closer than we think, right? Sine h over h is here times cos x. Okay. So what I can do, because it looks like I want these individually, I can rewrite this both over h, right? So what I've got is I've got a negative sine x times, and I'm going to rewrite the order here, 1 minus cos h over h So this is reversing the common denominator, right? Times the plus the cosec sine h, sorry, over h. Okay. All right. So now I'm there, I'm done. Might not see it yet, but what we can do is we can rewrite this as, well, we can change the order here to match what we've got here, but basically, let's just write a note here that we're done here. Oops. And then the rest is just that we keep going, just to make it look exactly like it. So I'm going to swap the order. Cosec sine h over h minus sine x 1 minus cos h over h. Okay. To make it look like, and I'll just drag this down here, make it look like this thing exactly, I can group this and I can group this. So what I've got is oops, let's rewrite the order again here. We've got this sine h over h times cos x, you can convince yourself that that's the same, minus the sine x of 1 minus cos h over h. Whew. Which is exactly what we wanted. All right. Any questions? So that one's harder, right? But there's only 2. Question?
Yeah, like here when we have cos x sine h over h, like when we split it into 2, isn't it we have to put h under the cos x also?
But because we're multiplying, that's the only reason that we're allowed to just put it over sine h. Because here, if we do sine h times cos x over h, it'll all be over h anyways. So so you're right. The only reason that we're allowed to make this split is because we're multiplying here.
Okay.
Right. Whereas here, when we were splitting and we had the addition, then both of them had to go over h.
Okay.
But that's really good, right? Because we don't want to be doing that illegally.
Yeah.
Good. But because we're multiplying, it's safe. And same thing here. Nice. Any other questions? Probably easier if you just unmute yourself. It's hard to know if you're typing a question or not. All right. Let me just check.
For the finals, like our exam.
Yeah.
I want to know that for the finals, our exam should be online.
Yeah, it'll be, so you'll do it at home. And what we were saying at the beginning of class was, I don't know what that's going to look like yet, if it's going to be all the sections that we've covered or just the new sections. But I'll let you guys know next week, because I should know by next week. But it will be done at home, and yeah, so and it'll be online. But I do want to see your work for it, so that's why we're trying to figure out how to do that. But yeah.
Okay, thank you.
No worries. All right, guys, any other questions? No? Then I will see you guys later. Oh, it's just us here, I guess. All right. Have a good weekend, you guys. See ya. Thanks, Chloe.